we'll learn how to perform cross-analysis, chi-squared independence testing, and Fisher's exact test using R. First, cross-analysis is a method for analyzing the relationship between two or more categorical variables. For example, it's used to examine associations or differences between variables in categorical data, such as gender and beverage preference, or occupation and education level. Let's start by creating the data we'll use in R. In this example, we have sample data with gender and beverage preference as variables. Using the table function, we can create a cross table, and with the prop.table function, we can calculate the proportion for each combination. To visualize the cross table, we'll use a bar graph with the ggplot2 package. This way, you can easily see how beverage preferences are distributed by gender. Now, let's begin the statistical analysis. We use the ggplot function to carry out the chi-squared independence test. Since the resulting p-value is greater than 0.05, we interpret this as there being no statistically significant relationship between gender and beverage preference. However, you may see a warning message. This is a common warning when the sample size isn't sufficient or there are cells with low expected counts. In such cases, it is better to use a more reliable analysis method than the standard chi-squared test. That's why we use Fisher's exact test. When you run the Fisher.test function, the p-value still comes out greater than 0.05. Although the odds ratio is calculated as 6.41, the confidence interval is extremely wide and includes 1. This means any difference between the two groups is not statistically clear. In conclusion, with today's sample data, it's difficult to say there is a definite statistical association between gender and beverage preference. If you collect more data, you'll be able to obtain more reliable results. I hope this video helps you understand how to practically apply cross-analysis and independence testing. The R code is posted in the community post.